So in the last class, we looked at pointers and we learned how to use pointers to write code to swap, to write a function which can swap to the contents of two variables. This is what we looked at in the last class. In today's class, we will study about arrays, and then what we do is and then we try to solve an interesting problem that is given a list of numbers. So how we can go about sorting those numbers. That's the goal for today's lecture. I think this is where we were in the last class. So here we have the main function, and we have declared that there is a variable called as an array. Its name is let's use it as so there is a variable a. It's an array of integers. And if you see, so before we kind of let's make it a simple thing. So let's say we declared an array of 10 integers. So let me print. So this array, this is a consecutive sequence of bytes. Consecutive sequence of integers. So in the memory, the way memory is allocated, this is very important. The way memory is allocated is if this is your main memory, so this is a of so a of 0. First get the basics right before we kind of move to more complex questions. A of 9. So like for example, if the base address of a of 0 element is 100, if the base address of the, so this is address of the 0th element is 100, then the address of the first element will be 100 plus 1, 104. So you can see each this one, it consists of 4 bytes. Okay, if I use a different pen and draw, so this is the 0th byte, this is the first byte. So this is, you can see there are 4 bytes within this entity, because integers require 4 bytes of, an integer requires 4 bytes of memory. So the address of the lowest byte would be 100. And similarly, if you see, this is again a of 1 is also 4 bytes. So the 104 points to the lowest byte address, right? So if you want to see how see if this is actually the case, let's try to write a program for int I is equal to 0, I less than 10, plus I, and so printf address of a of %d is equal to %p address of right. And also, in order to kind of make it bit more clear, we can so let's compile this program and see what happens. Okay. Sorry. Let me use /n. you can see, if you see here, the just focus on the last two digits. So you can see the address of the first element, it starts at E0. And the next element, it starts at E0 plus 4, E4. And the next element, you add 4, it will be E8. And if you add 4, then it becomes C. In hexadecimal representation, 12 is represented as C. So you can see that the difference between two consecutive addresses is 4. Yeah, maybe you can use the format specifier %lu you can use. Let's see what happens. So now you can see maybe this is better, as Siddiq rightly pointed out. So if you want to print it in just regular decimal form, the address of the 0th element is this. It ends with 36. The address of A of 1 is 40. And the address of A of 2 is 40 plus 4, 44. And the address of A of 3 is 44 plus 4, 48. The address of A of the next element is 48 plus 4, 52, so on and so forth. Are you all with me here? Do you see what is happening? And in fact, if you see, don't worry about that warning. So yeah, so one thing I would like you to observe here, let me clear the screen. GCC. You can see, if I just print the contents of the variable A is the array A, variable A, it contains the base address of the array. So when you declare something like this, so when you declare, when you have this array declaration, int A of 10, so essentially you are declaring the variable A as an array, and the size of the array is 10. But internally what compiler does is, the compiler uses the variable A to store the base address of the array. The base address of the array, if you can see, the base address of the array, that is the address at which the 0th element starts. So this and this, they are exactly equal to each other. Do you see this? Are you able to see this? An interesting thing what happens is, in the program, when we use something like A of 5, this gets translated into, internally, this gets translated into star of A plus I. But this plus I, this is a kind of, when we just say star of A plus I, you can write, instead of A of I, you can even write A of I plus I. That is, A contains the address, and to that address you want to add for I. But the actual value that gets added at the machine level is A plus 4 star I. Right? So this is what is called as raw address. This is raw address. So you don't write A plus 4 star I, but in the compiler, actually what compiler does, to compute the address is it multiplies this I with 4 because 4 is the size of each element. To get the actual address, this is what is this? This is the address of the element A of I. This is the address of the element A of I. So like for example, if A of 0, if I is equal to 0, then the address of A of 0 and address of whatever the content that is present in A, that is the base address that is present in array A, they are the same. So let's see, let's try to do one more thing. So I'll clear all this. So let's do one more experiment here. So I'm let's say we write a small loop for I is equal to 0, I less than 10, plus I. We say A of I is equal to I star 10. So in type. So this is where we are initializing an array. So now what we do is we print A of I in two ways is equal to %d star A plus I equal to %d I comma I comma E of I comma. So there is an interesting question. So whether I is declared two times. So when we declare I here, then the scope of the variable I is restricted to within this for loop. It is not visible to the next for loop. Similarly, when we declare I here, this I is restricted to this for loop. It is not visible outside. Like for example, on line 29, if I try to use I will get a compilation error. Okay, so the scope of this I, is restricted to the for loop on line number 27. So like for example, if I use something like I is equal to I plus 1 here, yeah, the compiler for is a function. No, for is not at all a function, Siddiq. It's just a statement. For is not a function. You can see on line number 30 that it is showing identifier I is undefined because the scope of the variable I is within this for statement. Thank you, Prachush, for correcting it. The scope of a variable need not be at the level of functions. Like, for example, it is possible for us. So this is a block statement and I can declare a variable j here and the scope of the variable j is between line 27 to line 30. It is perfectly fine. So it need not be for functions. Scope is not like defined with respect to functions alone. Are you with me here? Are you all with me? On the scope part. On the scope part, are you all with me? Okay. Yeah, it is there in King textbook. No, you have to read textbook. Not reading textbook and on. So yeah, so here on line number 30, yeah, let's go here. So let's see, compile this program. So now you can see that whether we access a of 0 or a plus 0 or a of 1 or star of a plus 1, it's just the same. Because what happens is internally a of I, it gets translated into star of a plus I. But it gets rough again translated at the compiler level. So this is all the red is in the programmer can also see it. But below that, what happens is this a plus I gets translated to a plus 4 star I. That is because a is a pointer to an integer array and the size of each integer element is 4 bytes. Does this make sense? This address gets translated to this. So you go to that address and then you read a sequence of 4 bytes, and that's what the element A of I is. Are you all with me here on this one? If you are all with me, then we'll go to the next idea. If A is a character array, then instead of multiplying this by 4, it will be, since the size of each character is 1 byte, so the multiplicative factor here will be 1 instead of 4, if A is a array of characters. Great. So yeah. So now let's do this. So let's first try to write a simple program, and then we will go to the sort. Maybe I will try to rename it max.c. Okay. So now let's try to read uh, an array, and so this is in the last class we have seen the code to. So now when we want to pass an array, so this is again one important idea here. So we are writing a function read array, and we would like to pass to the read array the base address of the array. So this is very important because once we know the base address of the array A, it is possible to change the contents of the individual array elements. And that is what is happening in the read array function. To the read array function, we are passing the base address of the array A on line number 28. Yeah, so let's make this the size equal to 30. On line number 28, we are calling read array function, and we are passing the base address of the array. Since we know the base address of the array, the address of the 0th element or first element or second element or third element can be obtained. And because of that, the scanner function will be able to successfully write into corresponding memory location. Are you all with me here? And at the end of reading the array, we are just returning the size of the array. And the way we declare the parameter type, if it's a single dimensional array, is like what you see on line number 3. On line number 3, that's what you're seeing on line number 3. It is, we are passing int we just put a empty square bracket indicating that we are passing the base address of an array. Are you all with me here? The syntax, the semantics. So if you kind of put a, let's see, this is maxarray.c, right? So can we use p of I if p is a pointer? So yeah, you can use that. Yeah, it should be possible, sure. So let's compile this. So let's put a breakpoint here. So if you see, guys, I want you to pay attention here. If you see here, this is in the call stack. So this is the call stack. In the call stack on line number 28, so in this program on line number 28, we are calling read array. And we are passing A as parameter. We are passing A as parameter. And if you see, right now, the array A doesn't contain some random values. And yeah. So now what we are doing is we are passing the base address of the array to the read array function. So now we go to the call stack and you can see this is the base address of the array. This is the base address of the array. Yeah, the read array function, it takes the base address of the array, not the whole array. Are you with me? So see, there are array A is not initialized before, so it takes some garbage value. Some are 0, some are non-zero. Let's not worry about them. The important idea that I want you to understand here is that we are calling the read array function. Main is calling the read array function, and it is passing the base address of the array. In fact, if you see the function signature for read array on the call stack, it says that that A is a pointer to an integer. A is a pointer to an integer. And that's what it is. It's A is a pointer to an integer. But the interesting thing is it's a pointer to an integer, which is the first element in a sequence of integers. No, address of A of 0 is equal to A. Are you all with me that we are passing the base address of the array A to the read array function? Yes or no? Are you all with me here? So because of that, on line number 6, it is possible for us to go read something from the keyboard buffer and assign it to the A of 0th element. So let's see here. So step over. So now when we do step over, where is this? I enter 10. So now if you enter 10, go to main and you look at A of 0, A of 0 is initialized to 10. So Balaramakrishna has this nice question. Should we use int star A or int A? But int A followed by square brackets is equivalent to int star A. Don't worry about it. So you just right now, the important thing that we want to convey is that we are passing the read array function, the base address of an array. And the way we do it is by making use of this notation, A of A followed by square brackets. So now you go ahead and now again, so I is equal to 2, and when you enter 20, so you can see, sorry, I is equal to 1, you read the 0th element, you read the first element, and you go and look at main, and if you see A of 1 is equal to 20. Because we are assigning the value that is read from the keyboard buffer to the element A of 2, to the element A of 1 here. So the call by value reference, call by value parameter passing mechanism, it's not a problem because we are working with addresses here. We are not working with the values, we are working with addresses here. So there is a question, the function doesn't know the size of the array. The read array function doesn't know the size of the array. So if there is a programming logic error, then you can overrun, you may end up reading elements whose size is greater than the size of the array, in which case your program can get into trouble. So while in the while loop 6, on line number 6, we need to have something like, we need to have some kind of check on line number 6 in the while loop, that if the size of that once we reach the size of the array, then we should stop reading, something like that we should do. Are you all with me here? Are you all with me? So in order to account for what what Arush mentioned, so we do something like this. We define a macro max size, and we kind of say here max size. You just put exit function now. We all have already seen that, Sanyam. We have already seen that. And max size is not a keyword. It is a macro that we are defining, that wherever max size is used, it gets replaced with 30. And here we say, while I is less than max underscore size, and yeah, max underscore size is replaced with 30 by the C preprocessor. We can use any word instead of max underscore size on line number 3, no problem. So if so as long as I less than max size, we keep going, we keep reading. Once I becomes equal to max size, then we can no longer read. So at that point, we exit. Does the code on line number 8 make sense? On line number 8 and 9, does it make sense? And there is one very important key feature in C which makes line number 8 work. Can someone tell me what is the key feature on line of C which makes line number 8 work? Otherwise, we could get into trouble. Yeah, short circuit. Exactly. Because let's say if I becomes equal to 30, then and if still the compiler goes and does scanf on A of 30, then there is a problem. But since once I becomes equal to 30, the first condition will no longer be true, and the second scanf statement will not be enabled. So because of that, this whole while loop works successfully. Yeah, short circuit and precedence. Okay. Max size is not stored anywhere. So wherever max size is there, it gets replaced by 30 in the source code of the program. Okay. No, see the thing I want you to, let's see, okay, since you are, so let's say before the code gets compiled, so you have this, there's a C preprocessor, which if you look at the C preprocessor, and this is the code for C preprocessor. If you see the output of C preprocessor, see how line number, the while loop in the read array got changed. Wherever max array is there, max underscore size is there, it got replaced with 30. Are you with me here? Your source code gets changed to this. Are you all with me? So your hello.c, whatever .c program, it gets converted. There is a program called a C preprocessor. So it converts this hello.c into hello.i. And in the hello.i, you don't see any of the macros that we are using. This is what is called as a macro. You don't see any of the macros. Are you with me on the C preprocessor thing? So the command is very simple. You just do cpp maxarray.c. That's what we do. Are you all with me here? Shall we go ahead? Shall we go ahead to the next set of ideas? What question you have, Mayank? You tell me. If you just use I less than max size, what will happen? See, you should think and ask a specific question. So what happens if you don't put scanf here, then if you don't use a second condition, so you end up reading. First of all, if you don't have scanf, it can't read any values. And if you keep scanf within the while loop, then you have to read all the 30 numbers. You cannot terminate the loop before that. That's what Sanyam is saying. Thanks for the clarification, Sanyam. I want you guys to think before you are asking, okay, so if I don't keep this, then what will happen? Okay, and then if there is a problem, you please ask. All right. So now let's see. Let's see. This is read array print. Yeah. So now let's run this program. gcc -g max array dot c. See, it just prints this. As I said in the last class, you can even is there any text file? Yeah. So you can even give input from text, like ./a.out less than input dot text. It will also work. It doesn't matter. So there is this interesting question. So if you see here, I can actually, I will give you an interesting thing. So we can kind of send the base address of the array as a of 1 and reduce the size by 1. And what happens? What will get printed? This is an interesting thing that I want you to pay attention. because the print array function, if you see the print array function, it takes the base address of an array and it takes the size. So it is possible for us to send the base address of the array as a of 1 and and then reduce the size by 1 and it prints a of 1 to a of the last element. This is an important observation because you can use this idea in many places like 1, 2, 3, 4, 5. So now only the elements 2, 3, 4, 5 are printed. Only the elements 2, 3, 4, 5 are printed. So before we do sort, I want to leave sort as a challenge problem for you. Let's take a simpler problem, which is a max array. So you want to find the maximum of an array. So it takes an array and its size as parameters, and it returns an integer. So what do we do? So initially, so we have int max is equal to a of 0. We think that the 0th element is the max element. And then what do we do? For I is equal to 1, I less than size plus I. And all we do is if a of I is greater than max, then the current estimate of max, then we make max is equal to a of I. And finally, we return max. This is our code. And does this make sense? The code for max array, does it make sense? Right? So now, let's not print array. So we say printf. So that's it. So let's compile this program. So we are calling max array function here. It returns a value. So let's compile this code. See, it prints 435. Nice. So if you see, so here you can change the base address of the array. Like for example, here, let's say I give the base address of the array as let's say 3, and I give the size as 4, then what will happen? What will be the output that will be present? If this is what I call it, what will be the output? Of course, it will be one element, but what will be the output? What other answers I have? Anyone else? Come on, guys. I want at least one correct answer. Thanks, Aish. Yeah. So the elements that would be considered is A of 3 is the base. Next is A of 4, A of 5, and A of 6. So max of these 4 elements will be given, because if you see the base address of this array that we are passing is the address of the element A of 3, and the size we are passing as 4. So what happens is this kind of, so the next 4 elements will be computed. So here when we say A of 0, the A of 0 is nothing but the base address of this array of A of 3. How many of you understood this now? That if we pass, what is the address that gets passed? The address that gets passed to here is the A of 3. Okay. And from there, 4 elements will be considered. Right? Great. So let's compile this program. Yeah, function interprets A of 3 as A of 0. So let's compile this program and GCC minus. So if you look at input.txt, more input.txt, okay. So this is input.txt. So input.txt contains, this is A of 0. This is no first element. This is second element. This is A of 3. So A of 3, A of 4, A of 5, A of 6. So these are the 4 elements. And among them, 45 is the largest. So 45 gets printed on the screen. No, A of 0, so Shreyas, A of 0 is not A of 3. So what is happening is very simple. What is the base address from the view of the max array function? What is the base address of the array? Can you answer this question? From the perspective of max array function, what is the base address of the array? Base address of the array is A of 3, address of the element 3. And what is the size of the array? 4. So the elements that it considers are A of 3, A of 4, A of 5, A of 6. That's all. And among them, it computes the max. So if you're all with me here, so now what I would like to do is I want to explain one sorting algorithm, and I want you to implement that sorting algorithm on your own. What is a sorting algorithm? It sorts the numbers in decreasing order. No, like for example, if it is 12, 32, -1, 45, 8, then the sorted list is in the increasing order, that is ascending order is -1, 8, 12, 32, 45. This is what we would like to print. So the algorithmic approach that I would like you to consider is what is called as a selection sort. So what you should do is you start with this array. Let me change. So this is the algorithm I want you to. I will explain this algorithm through an example. So you try to find the smallest element in this array. The smallest element in this array, and the smallest element in this array, it turns out to be -1, right? So you swap the smallest element with the, you swap it and bring it to the beginning of the array. You swap it and bring it to the beginning of the array. So after that, what happens is this is what -1 will be here, and then the rest of the elements will be whatever may be the rest of elements. Okay, so let's say maybe it looks something like this. So now you recurse again. So now what you have to do is you have to find now you leave -1, its position, we know the smallest element. So in the next iteration, you just consider this and you try to find the smallest element among the red elements. What is the smallest element among the red elements? It is 8, right? So 8 is the smallest element among red elements. So what do? You swap 8 with the 32. So this is what you get. You get -1, 8, and then you have maybe 12, 45, 32. So now again what you do is, now you focus again your attention on the red elements, and you find the smallest element among the red elements, which is 12. So 12 is in its good position, so we don't need to worry about it. So -8, 12, and you have 45, 32. So now what we do, you find the smallest element among the red elements. It turns out to be 32. So you swap, you have sorry. Yeah. So you have -1, 8, 12, 32, and then you have 45 left. Okay, so on and so forth. So essentially, you kind of start with you start with the whole array a of 0 to a of n minus 1, and you find the smallest element in this range. You find the smallest element in this range, and what you do is, after that, you kind of try to find the smallest element in this range, and then you try to find the smallest element in this range, so on and so forth. And so you always, whenever you find the smallest element, you move it to the beginning of the array. Okay, this is what is called as a selection sort algorithm. The challenge problem for you is, given this algorithm, can you go ahead and write a C program for this? And I would like you to, all of you, to give a shot at it, in show the same to me in the beginning of the next class. In the next class would be on Tuesday, I guess. Does this make sense? Is this an interesting problem to solve? Would you like to take it up and do? Good. So this is how you learn. So there is this is how you try to write programs, and you good. Yeah. So now in the last yeah, I'll take 10 more minutes and show. Yeah, then the point, if it's a character array, the pointers differ by one value. Yeah, that's true, by one. So just like we have seen 2D arrays, it's 1D array, we have 2D arrays also in some problems in your so when you're working with matrices, in mathematics, in linear algebra, you work a lot with matrices. So let's do a simple thing. So mat addition, matrix add.c. So we will write this code to read two matrices, and we will add two matrices and print them. So let's say the way you define two-dimensional arrays is this. Okay, like for example, I can have I can say hash define m is equal to 10. Okay, why 10? Okay, I'll just keep 2 in order to n is equal to 3, or maybe 2 itself. And so now we are declaring a two-dimensional matrix. Okay, so how are we saying it's a 2D matrix? We are saying it because it has two square brackets. And we can write a function matrix read matrix A and read matrix B. We read two matrices and then we say add matrix A comma B, and so actually we would like to have one more matrix C in which we would like to, we want to add A and B and put it in a target matrix. Yeah, so maybe I can keep it at the end in a target matrix C, and then finally we'll have a print matrix function. So here we say print matrix all right. So this is our goal. So one important thing I want you to understand is in the case of multi-dimensional arrays. So like for example, let's say if the matrix is a 2 by 2 matrix, then it will be like this. So this is 0, comma 0th element. This is 0, comma, this is the element in the 0th row and first column. This is the element in the first row and 0th column, first row, first column. So the way to access no, this element, the way we access is A of 0, 1. This is how we read. Yeah. And similarly, if you want to access this element, we use A of 1, 1. This is how we read. And the important thing is the way this gets laid out in the memory, because you know our memory is a linear sequence of bytes. So this 2D structure, it has to be laid out in the 1D plane. So what happens is we store in C, we store in what is called as a row major fashion. That is, first row will be stored, followed by the second row will be stored, followed by the third row, so on and so forth. This is A of 1, 0, and A of 1, 1. Maybe there is more memory down here. So you see, so this is what is called as a row major fashion of storing elements. Row major fashion of storing elements. So the A00 will be stored first and followed by A01, followed by A10, followed by A11, so on and so forth. Are you all with me here? So what happens is, if you, in order for you, the particular way in which we pass 2D arrays as parameters is bit different from the way we pass 1D array as parameters. So I will just use int, I just use matrix name as X. Okay, so whatever. So in a while passing a multi-direct, so while passing a multi-dimensional array as a parameter, we have to, we can leave the first square bracket free, but the second square bracket we have to fill it up with the size of uh, the number of columns of the matrix. There is a reason for it. The reason for it I will discuss in the next class. But for the time being, I would just say that if you are trying to work with the M by N matrices, while passing parameter, the way the parameter declaration looks like will be something like this. The first one can be empty, but the second one has to be the second index, the second dimension, N has to be there and it has to be fixed. Is it all right with you guys? Is it okay? Does it make sense? Are you all with me? Just take it for my word that on line number 5, when we are passing a 2D array as a parameter, the second dimension n has to be fixed. The second dimension n, it has to be passed. We cannot leave it like an empty square bracket. And there is a reason for it. The reason for it I will explain in the next class, but for the time being, take it for me that we have to put it there. Otherwise, it doesn't work. No, we cannot do x of m in there. I don't think it is allowed. The first square bracket has to be left as it is, if I am right. So, and how do we read this loop? So we write, for the first time, we are writing a two-dimensional for loop. For I is equal to 0, I less than m plus I, and then for j is equal to 0, j less than n plus j, and then we say scanf %d ampersand a of I, a of h. And I have a challenge problem for you. The challenge problem for you is, in your opinion, why does the C language compiler insist that the second dimension be given, but whereas it's not strict about the first dimension, that we don't need the first dimension? Why is it the case? In your opinion, why is it the case? I want you to think about this problem. I want you to think about this question, and maybe you can try to explain me in the next class why it is the case. Does this loop make sense? We are reading one row at a time. Shavak has a nice answer already. So, are you with me in the read matrix code that we are reading one row at a time? In the outer for loop, we are iterating for when I is equal to 0, we are reading the row 0. When I is equal to 1, we are reading row 1. When I is equal to 2, we are reading row 2, so on and so forth. No, it's not m comma n, Chikit, on line number 9. It is I comma j only. Does the read matrix function make sense to you guys? Does it make sense? Yes, no? So now that once the read matrix function is done, so let's try to write add matrix. Let me use S1 as a source 1. Okay, so there's a source matrix 1, source matrix 2, and there's a destination matrix. And here again, what we do, we write a 2D Does the add matrix function codes make sense to you? Does the add matrix function make sense? How many of you are with me? We are iterating row by row and adding corresponding elements. That's all it is. That's all the code we have here. Let's compile the code and see what happens. Oh, matrix, so let me have this thing here. printf enter a percent d by percent d matrix. Oh, print matrix is not there, huh? Okay, since we are almost there, we'll finish it, guys. Sorry, I'm overshooting a bit, but I want you to introduce this idea so that you can work on 2D matrices over the weekend, since we don't have a Saturday class. I hope you are able to understand what we are doing here. In the printf, we print a row and then we print a new line character. Thank you. So 10, 0, 0, 20. Okay, let me enter 0, minus 10, minus 20, 0. So you can see that that's what the output is. You're all good with this program? Does it make sense? We wrote 3 functions: read matrix, print matrix, and add matrix function. We read the 2 matrices, we computed the sum of the 2 matrices, and we have printed it. And here we used for loops within for loops. It's a 2D for loop, as we say. I hope that you understood this code. So please review this code, try it out, and so you're all enabled to start working on the loops. So that is the purpose of today's lecture. So let me stop recording and